Professor Belfrost's science class is back.
Welcome back to my class, and today we'll continue our lesson on the chapter of equations and inequalities, and this is the third video in this chapter. Okay, so let's review our last lesson. So irrational equations have a variable in the denominator in at least one of the terms, and we can solve it by finding the LCD, least common divisor, or in some case by doing cross multiplication. So the most familiar form of a linear equation is the slope-intercept form, written as y equals mx plus b, where m is the slope and b is the y-intercept. And the slope of a line refers to the ratio of the vertical chains in y over the horizontal chains in x between any 2 points on a line, and it indicates the direction which a line slants as well as its steepness. Another way that we can represent an equation of a line is by using in the standard form. So what is the standard form? Standard form is given as ax plus by equals c, where a, b, and c are integers. Then the x and y terms are on one side of the equal sign, and the constant term is on the other side. So lines that are perpendicular intersect to form a 90-degree angle, and the slope of one line is the negative reciprocal of the other. Okay, that's done for the review, and let's start our discussion today. So actually many applications are solved by using known formulas. And the problem is stated, the formula is identified, and known quantities are substituted in the formula, and the equation can be solved to find the unknown, and it is the answer. For example, we have area of a rectangular region, for example, which is a equals the length times width. Perimeter of a rectangle is 2 times length plus 2 times width, and volume of rectangular solid is the volume is length and width and height. So we have unknown that we can try to solve it by using the known information and try to rearrange the equation. Okay, so let's practice. So say that it takes Andrew 30 minutes to drive to work in the morning. So he drives using the same route, but it takes uh, 10 minutes longer, and he appraises 10 miles per hour less than in the morning. So how far does Andrew drive to work? So yeah, first we need to know that we need to apply a distance formula here. Say that d is the distance, r is the rate, t is time. So d equals rt. So it takes 30 minutes or half hour at rate r. So if he is driving home and takes 40 minutes, it means that it is two-third of two-third hour, and his speed averages 10 miles per hour less than the morning drive. And both trips cover distance d. So what's the same here is the distance d. So you can uh, write down and create a table to include all the information. So to work, d is d, r is r, t is half, and back to home, the d is still d, the r is r minus 10, and the t is two-third. I'm sorry, the table is a little. So we can write two equations, right? So d equals half time r to work, and d equals the difference between r and 10 times two-third when going home. So these two is actually the same, so we can put them side by side. So half r equals r minus 10 times two-third. And by rearranging and solving it, that we obtain that r is 40. So it means that the rate of speed to work is 40 miles per hour, and the return trip rate is 30 miles per hour. Now this is the answer, but this is not what we want. We want the distance, right? So distance, we can take one of uh, either equation. Say that we pick the easiest one, r times half. So 14 times half, which is 20. So the distance between home and work is 20 miles. Second example, so perimeter of rectangular outdoor patio is 44 feet, and the length is 3 feet greater than the width. So what are the dimensions of the patio? So we can write down, first we need to know the formula first. So formula is very standard. So perimeter is equal to length plus 2 width. Now we know that length is width plus 3. Then we just need to substitute it, right? Easy. So P equals, P is 54 equals 2 times length is W plus 3, and 2W is 2W. Okay, so W is 2W, so 2W plus 3, both are multiplied by 2. Then actually you can just simplify it first. So 54 divided by 2, the 2 times 2 W plus 3 is also divided by 2. So yeah, after some simplification process, then you know that W is 12, and because length is 3 units greater than the length, then the length is 15. So the dimension of the length is 50 feet, and the width is 12 feet. Now the third example, the perimeter of a tablet of graph paper is 48 inches, and the length is I'm sorry, I mistyped this something. Okay, it's blah 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 inches more than the width. So find the area of graph paper. Let's see actually what information I mistyped here. Okay, so area is very easy. Area is just length times width, and this is just standard formula. Okay. Oh, I'm sorry, that is 6. Okay, so the length is 6 unit greater than the width. Okay, or 6 inches more than the width. Okay, so we can write it L equals W plus 6, and yeah, you just using the regular way. Okay, so because we have known the perimeter, we can find the length and width first, and then we can use this to find the area. So yeah, perimeter is given, it is 48, and the length is W plus 6. Okay, so yeah, by using all the information substitute into the algebra expression that we have created, I mean the equation that we have created, we find that W is 9, and L is because 6 inches longer or more than the width, it is 15. Then by using the information, we just need to multiply them. I mean the length and the width, we just need to multiply it, and we obtain the area, which is 135 inches square. This is the third one. It's similar to the previous example, right? Now number 4, the fourth example. Find the dimension of a shipping box given that the length is twice the width and the height is 8 inches, and the volume is 1600 inches cubed. So here's how we solve it. Yeah, this time we use the formula V equals LWH, and we know the L is 2 times W, H is 8. So you just actually need to substitute X before, as shown in the slide, and we obtain that W is 100. So W square is 100, so W is 10. Okay, by using this, we know that length is 20 inches, W is the width is 10 inches, the height has already been given before, 8 inches. So this is the dimension. Okay, so now we are done with the concept of basic equation. Now we'll step into another equation, which is related to the utilization of the complex number. Okay, so what is complex number actually? I'll give you a simple picture. Okay, so yeah, negative integers, yeah, fill a void left by the set of the positive integers, and the set of rational numbers in turn fills a void left by the set of integers. That's what we have discussed in our first chapter, right? So the set of real numbers fills a void left by the set of rational numbers, and not surprisingly that the set of real numbers has voids as well. So this is actually just you know the subset, the superset things. Okay, so now in this section we'll explore another set of numbers that can find the set of the real numbers, and we'll see how to work out with it. So we know how to find the square root of any positive real number in previous chapter. Okay, and actually we can also find the square root of any negative number. So yeah, the difference is that the root will not be real in this time. So if the value in the radicand is the one inside the root, okay, the root symbol is negative, then the root is said to yield an imaginary number. Okay, so the imaginary number is defined as the square root of -1. So the square root of -1 is imaginary, or it is represented as symbol I, the notation of I in mathematics. Or in physics, sometimes you will use J, but I don't mind. This is just mathematical notation. Okay, you can use either way that you like. Okay, so the property is that I squared is -1. So actually, for example, you want to express the square root of -49. How to do it? You can actually separate them. So -49 is basically 49 times -1. So you can just square root the 49 first, take the square root of 49, it is 7, and take the square root of -1, which is I, and then multiply them together and yield 79. That's done. Easy. So actually, a complex number is the sum of a real number and an imaginary number. This is a new set of number that I want to tell you, okay? So yeah, you can express it in the form of a plus bi, where a is the real part and b is the imaginary part. So for example, we have 5 plus 2i, so 5 is the real part and 2 is the imaginary part. Same to if we have 3 plus 4i, a square of 3, then 3 is the real part and the 4 times square of 3 is the imaginary part. This is very simple. So imaginary numbers will differ from real numbers that a squared imaginary number produces a negative real number. But recall that when a positive real number is squared, then the result is a positive real number. And when a negative real number is squared, then the result is also a positive real number. Okay, that's what we have known so far. And complex number will consist of real and imaginary number. So given any imaginary numbers, we can express it in standard form of complex number by first write the square root of -a to be square root of a times square root of -1. So the square root of -1 we express it at I, and we just take the square root of a into account as we do the operation before. I just need to multiply them. So actually this is very simple. So yeah, that's to be said. Let's do example. So express square root -9 in standard form. Yeah, actually it's very easy, as by using the previous step before, we can obtain the answer, which is 3i. And to write it in standard form, we just, because it doesn't have a real number, so we just express it as 0 plus 3i. That's easy. We can plot complex number or number like as we might with real numbers, but we can still represent them graphically. So actually we need to address two components of the number. We use the complex plane, which is coordinate system, in which the horizontal axis will represent the real component and the vertical axis will represent the imaginary component. So it is pairs of point. Okay, so pairs is AB. A is for the horizontal, B is for the vertical. Easy. So for example, we need to plot the number -2 plus 3i. So -2 is the real part, and 3 is the imaginary part. So you can plot it as shown in the figure below. So here you see that the horizontal part is real and the vertical part is imaginary one. Okay, so yeah, here's the 4 steps that you need to use. You need to follow, I mean, to plot a number, a complex number or a complex plane. Okay, let's practice. So plot the complex number of 3 minus 4i on a complex plane. So let's solve it. So the real part is 3, the imaginary part is -4. It's very clear. So the ordered pair is 3 minus 4. and we can plot it as shown in the figure. Okay, so just as with real numbers, we can perform arithmetic operation on complex numbers, and to add or subtract complex number, actually it's very easy to be done. So to add it, just simply you group it, the real with real, operation of complex number with complex number. And subtract it also means the same. You do the subtraction operation, real with real, and the imaginary part with another imaginary part. Okay, so there are three steps that you need to follow up to find a sum or difference of two complex number. I want you to read it by yourself. Okay, now let's dive into the example. So there are three questions for you to two questions for you to practice. Okay, so the A is 3 minus 4i plus in bracket 2 plus 5i, and B is in bracket minus 5 plus 7i minus in bracket minus 11 plus 2i. So to solve for the first one, easy. You just need to take out the number from the bracket and just group them by their type. Okay, real with real, imaginary with imaginary, and it yields that the operation gives us 5 plus I as the result of the A part. How about question B? It's the same, but for negative you need to use distributive property. So minus into minus 11 plus 2i is actually yields 11 minus 2i. And after that you can just do operation as before. You group the real part with the real part and do the operation, and you group the imaginary with another imaginary part and do the operation, and it yields 6 plus 5i. How about multiplying it? Yeah, multiplying is easy if you're only dealing with a scalar. I mean, you're only dealing with constant, then it is very easy. You just distribute it. Okay, for example, with 3 times the sum of 6 and 2i, yes, 3 times 6 plus 3 times 2i, and it yields 18 plus 6i. Okay, also the set of 4 times sum of 2 and 5i, it yields 8 plus 2i, 20i as the step I've addressed before. But how to multiply two complex number? Actually, we can make use of a FOIL method. Okay, so yeah, FOIL, I want to recall it again. So FOIL is a shorthand for first, inner, out, and last term together. Okay, so but we need to notice though that the difference with complex number is that when we square I, it will yield -1. That's the point. So given that we have formed a plus bi multiplied with c plus di, it will give us the result of ac minus bd plus ad plus bc I. Actually, you just need to memorize this form. You can just following the step below, and you can get the answer. Okay, easy. So let's practice. Multiply this complex number. Okay, so yeah, if you want to follow up with that, it's okay. If you want to just distribute it one by one as shown in the slide, it's also okay. So you don't need to memorize the formula, and it yields 23 minus 40i. How about dividing? Dividing means yeah, dividing it will require a more complicated step than adding, subtracting, and multiplying, because we cannot divide by an imaginary number, meaning that actually any fraction must have a real number denominator to write the answer in standard form. So what we need is called a conjugate. Okay, so we need a complex conjugate of the denominator to multiply with the form that we already have. Okay, what is the conjugate? For example, we have a plus bi, then the conjugate is a minus bi. That's the complex conjugate actually. So if we multiply a complex number with a complex conjugate, also actually it will yield a squared plus b squared. Okay, so the result is a real number, and then after this the division operation can be done. Okay, So yeah, the formula of division of a complex number is shown on the bottom side of the slide. So I want you to pay attention by yourself. Okay, and yeah, after all the step we do to simplify it, then it yields the last formula which is shown in the slide. Okay, so CA plus BD plus AD minus CBI divided by A squared plus B squared. Okay, let's just practice. So first, you need to find the complex conjugate of each number. So A part is very straightforward. You just need to negate the I square root of 5 part to be 2 minus I square root of 5. It's easy. How about B? B have no real number. Actually, you can express it as 0 minus half I. Then you just negate the minus half I part to be 0 plus half I. Or because actually you don't need to express 0, you just write it simply as half I. That's done. Okay, so given two complex number, we can divide by following these 4 steps. Okay, I want you to memorize it or take a screenshot. So for example, we need to divide 2 plus 5i by 4 minus I. So how to do it? Easy. First, we find the complex number, the complex conjugate of the number 4 minus I. What is the complex conjugate of 4 minus I? This is 4 plus I. So you just multiply the division, okay? You just need to multiply the, yeah, I can say the division, right? By 4 plus I by 4 plus I. Okay? Then you just multiply two complex number by using the FOIL method or any method that you like. Okay? You can use the distributive property to done it. Okay? And the operation, I mean the calculation, yeah, the operation is shown on the right side of the slide. Okay? And at last, it gives us with the result. It is 3/7 plus 22/7 I. 17th I. 3/17 plus 22/17 I. And note that they express the question in standard form. But actually, the power of I are cyclic. So let's see. I raised to the power of 1 is I. Yeah. I squared is minus I. But I cubed is actually minus I raised to the power of 4 is 1, and I raised to the power of 5 is actually I. So it's cyclic. And we can see this cycle that actually is repeated continuously with I minus 1 minus I 1 every 4 powers. So let's practice if you have understood this concept. So please evaluate I raised to the power of 35. So since we know that I raised to the power of 4 is 1, then we need to know how many times 4 goes into 35. Okay, so actually basically 35 is 4 times 8 plus 3. So actually what we need to know is the I raised to the power of 3. But we know from table that I raised to the power of 3 is minus I. So actually that's the result. So I raised to the power of 35 is basically minus I. Okay, so we have done with the complex number operation. Then we need to discuss another one. This is quadratic equation. So what is quadratic equation? It's an equation that contains a second degree polynomial. For example, 2x squared plus 3x minus 1 equals 0, or x squared minus 1 equals 0. That is the quadratic equation. So how to solve this? To solve for a quadratic equation, then we need to factor it. It means to find expression that can be multiplied together to give the expression on one side of the equation. I think I've discussed factorization on a previous chapter, but we will review it once again in this chapter. So if a quadratic equation can be factored, so actually it can be written as a product of linear terms. Okay, so yeah, rather than explaining the theory, I want to go directly to the Example. For example, we need to expand the factor expression of multiplication of x minus 2 by x plus 3. So by multiplying it, actually we just distribute, okay, as shown, and it yields x squared plus x minus 6. And the product is actually a quadratic expression by setting equal to 0. Okay, so yeah, we can do the reverse, okay, because before we are given factor expression and we need to know the long form, the quadratic expression, but now we want to find the factor equation from the quadratic equation. How we solve this? So say that we have an equation of x squared plus bx plus c equals 0. Then yeah, with a is not equal to 0, then actually you can factor it by finding the, yeah, by finding the greatest common factor, the GCF. Is actually rather easy. Take for example, we want to solve the quadratic equation of x squared plus x plus 6 equals 0. And this is a quadratic equation with a coefficient of the second degree of 1. So there are 3 steps that we need to make use of to solve for this equation. So first is find two numbers whose product equals c and whose sum equals b. And then you use those numbers, write two vectors in the form of x plus k, where k one of the number found in step 1. Okay, and we just solve it using the zero product property by setting its factor equal to 0 and solving for the variable. So okay, so yeah, we need two for the problem before x squared plus x minus 6 equals 0. Then we need to find two numbers whose product equals minus 6 and whose sum equals 1. There are several possible factors, but the one that will work will is actually the last pair, which is 3 and minus 2. So we can write the factor as x minus 2, x plus 3 equals 0. And we set this to 0 and solve it. So x minus 2 equals 0 will give us x equals 2, and x minus 3, x plus 3 actually equals 0 will give us with x minus 3. And then now we can plot this as shown in the slide. Okay, that's done for our lesson today. I'll continue it on the next lesson. So here's a little quote for you. Mark Twain once said, "Never regret anything that made you smile." That's all for today. Thanks for watching. Subscribe, give a like, comment, and share this to your friend. I'll be back on every Tuesday and Thursday. So stay tuned, keep watching, and be thoughtful. And don't forget to visit our website on https://science with xysd.unax.com to access more learning resources that will be posted there. Okay, keep spiritual in your study, and I'll see you on the next episode. Goodbye.